I'm your instructor, Dave Semmelink from Go Digital SA Foundation. And today we're on Unit 4, Robotics, Part 1 of 2. Okay, so robots and robotics. Robotics involves the design, construction, operation, and use of robots. The goal of robotics is to design machines that can assist humans. Robotics integrates fields of mechatronics, which is mechanical engineering, electrical engineering, information engineering, and electronics, as well as bioengineering, mathematics, and other topics. And that is from Wikipedia. A robot is a machine that can carry out a series of actions automatically. A robot can be guided by an external control device, or the control may be embedded within the robot. Some robots look like humans or animals, but most are task-performing machines designed to perform specific functions. Robots can be autonomous or semi-autonomous and range from humanoids to industrial robots, medical operating robots, therapy robots, swarm robots, unmanned aerial vehicles, or drones, and even microscopic nano-robots. By mimicking a lifelike appearance or automating movements, a robot may convey a sense of intelligence or thought of its own. Autonomous things are expected to proliferate in the coming decade, with home robotics and the autonomous car as some of the main drivers. Okay, and that's also from Wikipedia. The idea of robots has been around for a long time, long before real robots were ever built. Animatronics, which is mechatronic puppets, resembling humans and animals, were designed primarily as entertainment. As technology progressed, more practical applications for robots appeared. Okay, so long before real robots existed, they were imagined and used for entertainment. These are not real robots. They are drawn in cartoons or are costumes worn by people or puppets controlled by people. In modern movies, they are created with computer animations. So if we look at these 6 examples of robots, this is a cartoon. This is a person in a costume. This is also a person in a costume. And this is computer-generated animation. This is also computer-generated animation. Only this is a real robot. This is a robot that was programmed to act like it's dancing. So types of robot. Okay, there's all sorts of different robots. Mobile robots, or automated guided vehicles, AGVs, can move items from one place to another. For example, to move items in a warehouse between the shelves and the delivery trucks. They can lift large and heavy objects and move them without requiring rest or breaks. They can be much faster than humans, and they don't make mistakes. Okay, so these are just examples. This is like a forklift truck. Okay, it's got a fork that lifts pallets of very heavy items, but you see there's no person driving it. This is a robot forklift. These robots work in a factory, as do these, and they go around collecting items from the shelves and bringing them to a delivery truck. Okay, industrial robots. They can lift, weld, and paint large items and work with very hot or very cold items and work in unhealthy environments. They normally are attached to the floor so they don't move around, but some can also move like AGVs. Okay, so these are just some examples. Here we've got a robot that's taking an item out of a furnace and it's going to move it to some other place. These robots are welding a car together, and these robots are painting a car. Industrial robots are also used in building construction. Here's a 3D printed house. Okay, the robot here is a 3D printer, and you can see that it's creating this house out of concrete. And here we've got a robot that lays blocks. So it can build a house out of cement blocks or bricks. Okay, so, and by the way, these videos are sped up. They don't operate this fast, but they are still faster than humans, and they can be more accurate, and they can use less materials, and so on. A service robot is a robot which performs services useful to the well-being of humans and equipment, excluding manufacturing operations. Okay, these robots help to deliver meals, vacuum clean the floor, and answer people's questions. Okay, so this thing is used in a hotel where it can deliver meals to the rooms. Okay, these robots will answer people's questions and guide them. And here's a Roomba. It's a very famous vacuum cleaner robot. These are popular overseas. It can clean the floor of the house while you're away. Okay, modular robots consist of components that can be connected together in various ways in order to adapt to new circumstances, perform new tasks, or recover from damage. Self-reconfiguring modular robots are able to change their own shape by rearranging the connectivity of their parts. Okay, so we can see that these are robots made out of components that snap together. So you can take the one robot and change it into this and change it into that. So you can change the configuration of the robot. And here we've got a robot where some parts are here, some parts are there. These parts can connect themselves together, and they can connect together in different ways. And this is a robot that's meant to assemble a space station out in space. And so all the robot parts will do different things, and they reconfigure themselves depending on what task they are doing. Okay, collaborative robots, or cobots, are like service robots, but they have been made very safe to work with. They typically work very closely with a person, like an assistant working with an expert. Okay, so here we've got people who are working in some sort of industrial setting, and this robot is helping them to do their work, as is this one. Medical robots include surgical robots, which can do precision surgery at a very small scale. They also enable a surgeon to perform operations remotely. Okay, so these robots, they've got very steady hands. Surgeons are famous for having steady hands, but these can be even more steady than a professional human surgeon. They can also operate on very small things, and they can work by remote control. So this doctor here could be in a different room, could even be in a different building, or in a different town, or a different country. Okay, so robots have moving parts, so we need something that can make something move, controlled by a computer. A DC motor turns an axle at a speed and direction determined by the voltage applied to its terminals. Okay, here we've got a DC motor. It's connected to a wheel, and the voltage that you apply, as you increase the voltage, the speed will increase, and if you reverse the voltage, the direction will reverse. A stepper motor can change its position by an amount depending on the signal applied to it. Okay, so here's a stepper motor, and it turns just like a DC motor, but the controller applies pulses to it, and the pulses tell it how much it should turn by. And that's useful if you need to turn by very small specific amounts. A servo motor turns by a certain amount depending on the signal sent to it. It can't turn more than 360 degrees, and most turn up to 180 degrees. Okay, so here's a servo motor, and it will turn, most of them will turn up to 180 degrees. Okay, and the solenoid pushes or pulls. This is a solenoid. When you apply a voltage, it pulls. When you disconnect the voltage, it lets go. The controller or computer tells the robot what to do. We will use a microbit for our controller. It is able to make a signal that can tell a servo motor what to do. We'll see just now how we can tell the computer to control a servo motor. Okay, so we are going to connect a servo motor to a microbit. It needs 3 wires. There's a ground or earth or 0 volt connection. There's a 3 volt connection. So these are power connections. And then pin 0 is connected to the 3rd wire, and that's the control signal. So this signal is controlled by our program that we're going to write, and that will tell the servo motor how much to turn. Sensors allow a robot to sense the environment. Common robot sensors include the ultrasonic distance sensor, which allows it to determine how far it is from an obstacle, or a light sensor that detects a line that the robot needs to follow. There are many other sensors that can be used by robots to detect ambient light, temperature, sound, position, motion, magnetic fields, gases, and so on. Okay, so this is a distance sensor. It's an ultrasonic sensor. So it's got one side that transmits an ultrasonic signal, and it's got another side that collects that signal. And so depending on how long it takes for the signal to bounce off of something, that tells the robot how far away something is from the sensor. And this is a light sensor. It has an infrared LED which shines a light, and then it's got an infrared detector which detects that light being reflected. If a light shines on something bright like white paper and it's reflected back, it will say that it's being reflected. If it shines on something black, then there's no signal coming back, so it says that it doesn't see something black. And we'll see how that's used later on. Okay, and this is just some of the many sensors you get. You can see there's temperature, force, load, or pressure, leaks or water levels, electricity, magnetism, RFID, we'll look at that later, ultrasound, you've seen that, acceleration and tilt, vibrations, position or proximity, chemicals or gas, acoustics or sounds, flow rate, ambient light, machine vision, humidity, moisture or water, and motion, velocity, displacement. So those are some of the many sensors that exist. Okay, our first robot. Let's see how we control a servo motor with the microbit. Okay, so we open our browser, we go to makecode.microbit.org, and we're going to create a new project. And I'll call this robot 1. Okay, so now we want to connect a servo to the microbit and write a program to control it. So let's say that on button A pressed, we want to turn the servo. Okay, so where do we find the servo? We go down to Advanced, Pins, and you'll see Digital Read Pin P0, Digital Write Pin P0, Analog Read Pin, Analog Write Pin, Map, Analog Set Period Pin, Servo Write Pin. Okay, so this is to write a value to the servo, controlling the shaft accordingly. On a standard servo, this will set the angle of the shaft in degrees, moving the shaft to that orientation. On a continuous rotation servo, this will set the speed of the servo, with 0 being full speed in one direction, 180 being full speed in the other, and a value near 90 being no movement. Okay, so we're going to take this and let's say on start, we want to start the servo in the middle. And you can see that we can change it from 0 to 180. The middle will be 90. So I'll put it in the middle. If we want exactly 90, we can just type in 90. So on start, we want to move the servo to the middle. Now you can see that as soon as we put the servo right block in the work area, the emulator shows us a servo. And it shows that we have the red wire, the red or orange, connected to 3 volts. The ground wire is connected to ground, so that's our 0 volts. And then the signal wire is connected to pin 0. So these two provide power to the servo motor, and this pin is going to send a signal telling it how much to turn. Okay, so on start, it's moved to the center. So let's say on button A pressed, we want to move it all the way to one side. So we can go back here, say servo right. And we can set it to 0 degrees. Okay, so what happens when we press button A? You can see that it's moved all the way to this side. And let's take button B. And we'll move it all the way to the other side. Okay, that's already 180. Okay, so A moves it all the way to one side. B moves it all the way to the other side. And let's just do one more. Let's say if we press both A and B buttons at the same time, it should go back to the center. And again, I can just type 90. Okay, so A takes it all the way that way, B takes it all the way the other way, and A and B pressed at the same time takes it back to the center. Okay, so that's a very simple example of how we can control a servo motor from the microbit. Okay, so let's see how we can control an actual robot. We're going to work with a robot kit. And this robot kit is a little device. It's got motors and wheels, and it's got a socket for the microbit, and it's got batteries, so it's completely self-contained. We're going to write a program that we put onto the microbit, and then the robot will be able to run on its own. We'll just take a look at the robot kit itself. If we look at the top of it, we can see that we've got 2 LED lights. These are like car headlights, except that they're red. We've got an infrared receiver. We can add more servo motors on these connectors. This is the wheel from the top, this is the other wheel, and these are the motors that run the wheels. So it's got one motor on each wheel. That means that we can turn it by turning the motors at different speeds. And there's the socket that the microbit is going to sit in. Okay, if we look at the bottom, it's got these 2 LEDs that we can control. And then it's got line following sensors. There's a sensor here and a sensor there. So this sensor has got an LED that shines an infrared beam at the ground, because this is the bottom of the robot. And it's got a sensor that picks up the reflection. And it's got 2 of these. So if we draw a line on the floor, then these sensors can be used to see if the line is between the 2. That way we can write a program so this robot will follow the line that we draw. And we'll see how that works just now. We're going to go to our development environment. And before we can do anything else, we have to import a library into the development environment that supports this particular robot. So these are the instructions. We're going to go to the control icon, and we're going to add a library package. We're going to give it the URL where it's going to find that library on the internet, and then we're going to import it, and then we should see that we've got this new section called McQueen, because this is a McQueen robot. Okay, so we're going to create a new project. We'll call this Robot 2. Then I'm going to go to this control icon. I go to extensions, and I'm going to enter the URL here. And it comes up with McQueen, an affordable mini robot designed by DF Robot. Okay, so I'll select that. Okay, now when we look into the block list, we see McQueen is a new section here. So this will give us all the controls we need for the robot. So let's try to get this robot to move forward for 1 second, then turn right, and move forward for 1 second, then turn left, and move for 1 second, and then move back for 1 second, and then turn to the right for 1 second. And we just want this to go on forever, so we'll put it inside the forever block. So we've got 2 motors on the robot, one for the left wheel, one for the right wheel. So we'll go into McQueen, and we'll say motor, choose the motor, and we enter the speed. So I'm going to take this, put it there. Let's make it bigger so it's easier to see. So we want the left motor to move forward at a speed of, okay, the maximum speed is 255. So let's just try that. And we want the other motor to also do the same. So we say the right motor should move forward at that speed. Okay, so the motors are now going to move at that speed, and we want it to do that for a second. So we tell the program to pause for a second. So 1 second is 1,000 milliseconds. Okay, so the left and right motors are going to move forward at the top speed. Now we want it to turn. How do we turn this robot? If we have one wheel going at one speed and the other wheel going at a different speed, it's going to turn. So if the left wheel moves at the same speed as before, but the right wheel, let's say it doesn't move at all, then because the left wheel is going fast, the right wheel isn't turning at all, it's going to turn to the right. So we'll let it do that for 1 second. Then we want it to turn the other way for 1 second. So we'll do the same thing. I'm just going to duplicate the blocks. Now the left wheel, I'll just type it in, will not turn. The right wheel will move at top speed, so now it's going to turn to the left. We'll do that for 1 second. Then we let it move forward again. Okay, I'm going to duplicate this. Duplicate that. And we pause for 1 second again. Okay, so for 1 second, both will turn at the same speed. So it should go straight forward. And then we'll get it to turn to the right again. Okay, so this is our complete program. It starts with both motors going at the same speed, so it should go forward for 1 second. Then the left motor carries on while the right motor stops, so it should turn to the right for 1 second. Then the left wheel stops and the right wheel turns. The right wheel spins at the top speed for 1 second, so it should turn to the left. And then both motors turn at the same speed, so it will go forward for 1 second. And the left wheel moves and the right wheel doesn't, so it should turn to the left for 1 second. And because it's in the forever loop, it's going to go back and carry on doing this over and over and over. So it's forward, right turn, left turn, forward, right turn, forward, right turn, left turn, forward, right turn. So because there's one extra right turn here, we'll see that it will keep on turning to the right. Okay, so let's download this to the microbit. And to do this, we need to connect the microbit via USB cable, and then we'll plug it into the robot, connect the batteries, and we'll see what happens. So let's start by switching to the desktop camera. And now here you can see I've got my laptop computer here. And there's a USB cable, the microbit, and the robot. The robot has got two wheels, one on the left, one on the right. Okay, and it's got a wheel in the front. The wheel in the front just keeps it stable, it doesn't do anything. The right wheel is connected to a motor, and the left wheel is connected to a motor. So we're going to control these two motors to make it go straight, or turn left, or turn right. So let's start by downloading the program to the microbit. So I click on download. And then it says downloaded. So I can disconnect it. I can now plug it into the robot, into the socket. Okay, so now the microbit is plugged into the robot, so I can control the motors and everything else on the robot. There's a power switch in the back that connects the power from the batteries to the robot and the microbit. If I turn the switch on, you'll see that the wheels turn. And you can see that they stop and start according to the program. Okay, so let's put this on a larger space so that it can move around. So now we're going to switch to the floor camera. Okay, so now it's got a lot of space to move. I'm just going to put it down on the floor and turn it on. So we should see that it will move straight, then turn right, then turn left, move straight, and then turn right again. So it's straight, right, right, left, right, straight, right, left, straight, right. Okay, so we can see that it is following the program. Okay, so there's our first program. We've created an autonomous robot that moves on its own according to the steps in the program. Let's see what else we can do with this robot. For the next experiment, we want to use the ultrasonic distance sensor to determine how far away the robot is from an object. That way, it can check to see if there is something in its way, it can turn away from that obstacle. So let's see how that's going to work. We'll start a new program. A new project, we'll call it Robot 3. We need to re-import the extension. That was McQueen. And here we see McQueen. We just want to check the ultrasonic sensor. So we need to read the ultrasonic sensor. And because this is a variable, we need to do something to show the value. So we're going to go to our basic block. We'll say show number. We'll put it inside the forever loop. So forever it's going to show the value of the ultrasonic sensor. Okay, now our simulator is showing something, but it's not the actual sensor, so we need to download it to the microbit, and then it will display the actual distance. So let's do that now. So I'll take the microbit out of the robot, plug it into the USB cable, and then we'll download that program. It says downloaded. So now I can disconnect it. Let's go back to the table camera. So I'll plug the microbit into the robot. And turn it on. You can see it says 6, now 7, 8 and 9, 10. It's measuring the distance in centimeters. Okay, so that's 3 centimeters. 4 centimeters, 5 centimeters, 6, 7, that was 6, 7, 8, 9, 10. So we can use this to get the robot to move in a straight line, and then when it sees an obstacle, let's say at 5 centimeters, then it will turn left or right, and then it will carry on until it finds another obstacle, and then it will turn left or right. Okay, let's see how we're going to do that. So we'll change the program. We want a condition if it's closer than a certain amount, then we want it to turn. Okay, so we're going to have a conditional. Let's say if and we want to check the distance that the sensor unit is returning. So we're going to do a comparison, and we're going to compare the value from the ultrasonic sensor. So we'll say if it's less than let's say 10 centimeters, then we want it to turn left or right. So we'll just start by setting the speeds. And you remember that we set left or right, but we can actually set both motors. Okay, so if we set all motors, or both motors, to move forward, then it will move in a straight line. But if we want it to turn, we can say left motor should be on, and the right motor should be off. So that will turn to the right. Okay, so if it's less than 10 centimeters away from something, then it will turn to the right. Okay, otherwise we want it to go straight. So here's where we say all motors should go, so be turned on, so it will go in a straight line. So if it's less than 10 centimeters away from something, it will turn to the right. Otherwise, it will move in a straight line. Okay, so we'll download that to the microbit, and we'll see how it works when we put it on the floor. So I'll take the microbit out, connect it to the USB cable again. Download. It's downloaded. We'll put it back in the robot. We can just test it. I'm going to turn it on and see what happens. So both wheels are turning. Okay, when it's too close, then only the left wheel turns. Left wheel is turning, right wheel is not turning. When it's farther away, now they both turn. Okay, we'll try that on the floor and we'll give it a few obstacles. Okay, so now it's on the floor and I've made a ring around it. So we expect that when it approaches any of the sides here, any of the pieces of wood, then when it's within 10 centimeters, it will turn to the right. Let's see what happens when I turn it on. Okay, that didn't work so well, and it's probably because it's too close. So 10 centimeters wasn't enough time for it to turn. So let's change the program so that it turns when it's within, let's say, 30 centimeters. So all I have to do is to change this to 30. Now I need to download it again. Okay, I'm just going to connect the microbit to the USB cable. And download it again. Okay, so now it's going to turn when it's within 30 centimeters. Let's see what happens now. Another problem we might have is that it hasn't been given a chance to turn enough. To give it some more time to turn, after telling it to turn, I want to tell it to carry on turning for some time. So let's just say that if it has to turn, we also give it some time, let's say half a second. So it will turn for half a second before it carries on going straight again. Or actually, it will turn for half a second, and then it will check the distance again. So if the distance is okay, then it will carry on going straight. Otherwise, it will turn again for half a second. So let's try that. And again, I'm going to connect the microbit to the computer, download that again. Okay, so it's finished downloading. And we'll try that again. Okay, it's not perfect, but you get the idea. Another thing we can do is, instead of turning to the right, if we have no idea what the obstacle course looks like, we don't know if it should turn to the left or the right. So what we could do is to turn left or right at random. So what we can do is, if it detects an obstacle, then we want to say either turn left or turn right. So I'm going to put it in another if. And then we'll create a random value. We'll take a random number between 0 and 1. And we'll do a comparison. So if the random number between 0 and 1 is 0, then we turn to the right. Okay, so now if it's within 30 centimeters, we pick a random number between 0 and 1. If it's equal to 0, then we turn to the right. Otherwise, we turn to the left. And if it's more than 30 centimeters, then it will just go straight. So we'll try that. And let's try that now. Okay, not perfect, but we're getting the idea. One important thing that you might notice in robotics is that timing is important. So we need to adjust the time that we allow it to turn and so on. You might have noticed that when it gets very close to an obstacle, it seems to get confused. I want to make a small change here. Let's say that when it's very close, instead of turning, it should go in reverse. So what I'll do is I'll add another condition. So we'll say that if it's less than, let's say, 4 centimeters, then instead of turning, let's just get it to go back a little bit. So I'll get both motors. So motor all should move backward. And we'll leave it at the top speed. So now, if it's less than 4 centimeters, it will move backwards. And we can do that for, let's say, half a second. So we'll move backwards for half a second. Otherwise, if it's less than 30 centimeters, and let's make this a little bit smaller as well. Let's make this 10. So it can get closer to the obstacles. So if it's less than 10, then it should turn. And otherwise it will be more than 10, then it can go straight ahead. Let's try that. I'll download that to the microbit. Okay, that's downloaded. And one other change I want to make, you'll notice that it's reading the sensor twice. Ideally, you just want to read the sensor once and then check to see what the value was. So instead of reading the sensor here and then reading again here, we're going to read it once and set it to a variable. So I'll create a variable. I'll call it distance. And every time around the loop, I'll start by setting distance equal to the value from the sensor. I'll then check the value of distance each time. So if the distance is less than 4, then it will go in reverse. If the distance is less than 10, then we'll turn left or right. And finally, one other thing we can do for debugging. I want to find out why it is that when it's close to the obstacle, then it just is going forward instead of turning or reversing. So I'm going to display the value. I'm going to show the value of distance on the display so that we can debug that problem if we still have it with this version of the program. Okay, Well, let's try this. I'll download it to the microbit. And now we can try it again. You'll notice that I've made a small change to my setup. I've raised the height of the obstacles because they were too low for the ultrasonic sensor. So now it will measure the distance better. So let's see how this works. Okay, not a great success, but a bit better than before. Okay, so you'll see that there's a lot of things that you need to keep in mind. That's the time of how long it should take to do the turns, how long it should move in reverse, and so on. So you have to get the timing right. Okay, in this unit, we looked at what robots and robotics are about, and we started to look at how robots are designed and built. In part 2, we will continue to experiment with robots. So, I'll see you then.